After its initial vibrant phase, Mars began a long, slow descent into environmental chaos that would irrevocably change its face forever. The planetary shield, that crucial magnetic field, started to fade away, leaving the young world completely vulnerable to relentless, energetic solar winds. This cosmic bombardment quickly stripped away the protective layers of the atmosphere, causing global temperatures to plummet to incredible, freezing lows. The once mighty rivers that carved canyons across the surface visibly slowed their currents before drying up completely, turning lush lake beds into arid cracks. Vast, ancient oceans simply vanished, the water either boiling off into space or sinking deep down to become massive, frozen deposits hidden far beneath the Martian regolith. The resulting surface became a landscape of perpetual thirst, where the last remaining moisture retreated permanently underground or locked itself away in permanent, icy prisons. Even the familiar rhythm of seasons remained active on the early planet, although they manifested in far more brutal and unpredictable ways than anything we experience now. Gigantic, planet-engulfing dust storms became a recurring nightmare, sometimes blotting out the sun's life, giving rays for what felt like an endless succession of months. Powerful volcanic activity occasionally flared up, momentarily pumping warming gases back into the thin air. But these ephemeral effects never managed to reverse the overall climate trend for long. However, even amidst this surface turmoil, pockets of potential habitability likely persisted deep within the planet's crust for an extended time. Shelters existed in deep, isolated underground water reservoirs, within pockets of stable geothermal warmth, near ancient volcanic vents, or trapped in concentrated, highly salty brine deposits. Researchers now theorize that if any tenacious Martian life ever took hold, it would have retreated to these protected subterranean havens to escape the growing surface hostility. Slowly but surely, this dramatic environmental collapse sculpted the planet into the dusty, ochre desert that we observe through our telescopes today. The pervasive iron within the rocks reacted relentlessly with the scant remaining elements, causing the famous oxidation process that painted Mars its iconic rust-colored hue. With surface water largely gone, the tireless, abrasive wind took over as the primary sculptor, carving out massive, shifting sand seas, sheer canyons, and sweeping desolate plains across the terrain. The vibrant, dynamic world faded into a much quieter, colder, and profoundly more isolated sphere, drifting silently through the solar system. The epic, tragic history of early Mars tells an incredibly powerful and sobering story about the devastating potential fragility of planetary evolution across the eons. This deep cosmic history serves as a stark reminder that even worlds blessed with water and the possibility of biology can lose those vital elements across deep time. What remains now is only the silent, powerful evidence of that lost potential, subtly inscribed across every single layer of stone and every grain of crimson dust.